All right, we'll get started. Go ahead and respond to the online poll if you haven't done so already for your attendance. And okay, I know you guys are probably wondering about your midterm exams. We have not graded them yet. Okay, I'm getting together with my TAs and graders tomorrow. Okay, that was kind of the date in our schedule that worked out. So we're gonna get together with them tomorrow. We're gonna try to do all the grading, and so you can expect your midterm grades to be posted probably by the end of tomorrow, okay? Let's see. Some of you had issues with homework grades and stuff like that. You might have issues with the homework 3 grade and stuff like that. Please don't send me emails about your homework grading issues, okay? I will handle, if you have an issue with your homework grade, come see me in person, okay? Come see me in person and I can take care of your homework issues, whatever, come during office hours. I don't do homework stuff over email. It's too messy. I often have questions and I just don't want to have to deal with the the back and forth and stuff. And I know anyway, so if you have grading issues, come see me in person or go see your TAs in person as well. What else? I see on Piazza, I see a lot of questions and things, and that's great. There's a few questions, however, that can probably be solved with a little bit of Google. Things like a lot of times you'll get error messages, okay? And so if you encounter an error message and you have no idea what this error message means, try searching Google for that exact error message, okay? Now, obviously, if your error message includes a variable name, like if you created something called baseball and the error message says, you know, blah, 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 error and something referring to baseball, blah, 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 then remove the word baseball in your Google search for the error message, okay? But a lot of times there's other parts of the error message that, you know, the functions or the packages just kind of spit out, and a lot of times you can Google those. Somebody else will have encountered the exact same error message, and they hopefully will have found a solution that will work for you. A lot of problems are from using old software and old packages, and so this is my just ever reminder to update your software, update your packages. You should try to use the latest version of everything, not just for R, but you know, for everything else on your computer and on your phone and things like that. And I know sometimes that means features you used to love went away or whatever, you know, when you update to the newest app version of, I don't know, whatever it might be. You know, features that you loved are now gone, and now they're imposing new features that you hate, and maybe it forces you to delete the app or whatever. But in general, we are powerless to change the decisions that have been made about software updates. And so in order to keep things running on your machine, you kind of just have to go along with whatever has been updated. Let me see if there's anything else I want to say. Well, anyway, as they come to mind, I will let you know. Okay. On Wednesday, we introduced ggplot2, the grammar of graphics, and we said a few things about this. And the big idea in the grammar of graphics is that all of your data sets have to be tidy, okay? And in tidy data, each column is a variable, each row is an observation. And when we create a plot in ggplot, we do aesthetic mappings between the visual attributes to a variable in the data, okay? So for example, here we have a simple scatter plot, and we are representing each observation with a point, okay? And so those observations have different properties, and those observations are expressed in the columns, the variables in the data. When we represent them with a point, the points have properties, okay? And in our case, they have an x position and a y position. And so what we have done is we've said the x position of our point is going to be mapped to the x value column, and the y position of our point is going to be mapped to the y value column, okay? And so this is our data frame. 4 observations, 3 columns. The x value, the y value have their own columns, and we are mapping these columns to attributes of our data. I mean, attributes of our points, visual attributes of our points, okay? Here we have a 3rd column in our data, the group variable, and we can map that to another visual or aesthetic attribute of each point. So we can say the group variable is going to be mapped to the color of the point. And when we do this, ggplot automatically creates some colors for us. We've got red and bluish points, and it creates a legend for us, which is nice. Okay, and so the big idea of ggplot is that everything in our data, okay, each variable must have its own column, and what we can do is we can map visual properties of the point, or visual properties of the bar, visual properties of whatever geometric object we are creating to a column in the data. All right, and that is the fundamental idea in ggplot. Okay, and this often requires us to restructure our data into tidy form. We might have different kinds of things, and the data that we produce may not necessarily be in tidy form, and so if you want to use ggplot, you have to restructure your data into tidy form, 1 variable per column. All right, and if and that in of itself can be a hurdle, so you often have to use tidyr to clean up your data. One thing to note is that in ggplot, the command for ggplot creates an object, okay? So back here, when we first created our first plot back here, we created this object using the ggplot command, okay? So we said ggplot plus geometries. So this created a plot, and what we've done is we can say, let's store this plot, ggplot, into this object P, okay? And so then when we call something like P plus geometries, it produces this plot over here. The thing about this is that, clear this out, is that it just creates the object and it doesn't necessarily produce a graph, okay? So, which feels strange because so far we've just been calling P plus geometries and it produces the graph. However, that's because R's default behavior is that when you create an object, or not create an object, when you type in the name of an object, it's going to print it out, right? So if I say I is 10, and I do I plus 3, it will print out 13, right? However, if I do this, let's say for I in 1 through 5, and I say I plus 3, and I run this command, what will be output to the console? Will we see anything on the console? So if I run this, nothing gets output to the console, okay? You might have expected to see 4, 5, 6, 7, 8, but all it's doing is it's just doing I plus 3. It's doing this calculation, but it's not assigning it, it's not being told to print it, right? So when you run this loop, you have to say something like print I plus 3, okay? And if I run this, then we will see 4, 5, 6, 7, 8. Okay, because it's going to do I for 1 through 5, and it's going to print out I plus 3. The same kind of thing happens in ggplot. Okay, so let me load up just a simple data set from our thing. Where did it go? Okay, so we're going to create this simple data frame. Okay, and let's say I want to create a scatter plot, right? So if I do ggplot plus geom underscore point, all right, it creates our scatter plot. If I put this in here though, say like for I in 1 to 2 or something like this, let me just delete everything out of here. Okay, when I run this command, it doesn't produce anything, okay? Because all it's doing, this is basically the same as doing I plus 3 without calling print on it, okay? So if you want this plot printed, you have to call print on this entire thing. Okay, so this will create the object, and then you have to call print on it, right? And so when I do this, this will create the same plot twice. Okay, so when I do that, here's the plot, and indeed, you can't tell, but it has created the same plot twice. Okay, so this is just something you have to keep in mind, especially if you're going to try to run ggplot inside a loop or inside a function or something like that. You need to call print on it. So a lot of times you might create an object called p, and then you'll call print p on it. Okay, and what this will do is it will print each one out. Okay, so for example, I can do what is how do I do ggplot title? Title is done via plus gg title. Oh, I should have known. Okay, so for example, if I wanted this, I could call it gg title, and we will do paste. This is plot blank space I, right? Okay, and then so this will get produced in plot P. Let me just delete everything out, and I'll click run, and so here we have, this is plot 1, and this is plot 2. Okay, so it's producing each plot, and it's producing them here. Okay, so if you wanted to make plots as part of a loop or something, you have to explicitly call print on the thing. Otherwise, it will kind of just produce these things and they'll disappear. Not actually get produced. Okay, so anyway, that's what this slide says about printing. Any questions on that? All right, another thing is ggplot can do stats for us. And what that means is that remember, the central philosophy in ggplot is that each column represents a variable, okay? And so when you create something like a histogram, you are not actually plotting the values in that column. You are doing a bit of transformation work. So if you've ever created a histogram by hand, this is very clear to you. Excuse me. So for example, if you wanted to create a histogram for people's height, what you would have to do is somewhere along the way you have to make a decision about how many bins you want and what values will go in each bin, and then you have to go through your data set and you're going to say, okay, I've counted 6 people that go into this bin, I've counted 10 people that go into this bin, and something like that. So then you've created basically a new table of bins and the counts for each of those, and then you create bars, you create a histogram based on that summary table that you've created based on the bins. What you've done is you've done a statistical transformation on that column of height data before you've created a plot. Okay? So you have to think sometimes this has to go on in the background. Now, fortunately for us, because histogram is such a common concept in statistics, ggplot has this already made for us, and you can call geom_histogram to make a plot, but to make a histogram plot. But other times, you know, there might be plots that you want to make, and you have to just be mindful of any kind of summary statistics that are being performed before the plot is being done. Okay. All right, now we can get into a little bit more details on some of the ggplot geometries. Now, as far as this class and this lecture goes, we're only going to cover kind of the three basic ones: geom point, geom line, and geom bar. Okay, so basically point geometries, points, lines, and bar plots. Okay, and I think that's good for a basic start, and and it's enough to illustrate kind of how ggplot works between mapping the variables, the columns in your data, to aesthetic attributes. Okay, but there are tons and tons and tons of other geometries that you can produce, and so for all of that, just, you know, into your browser bar, type in ggplot, and the very first or the second hit will be basically just the regular old ggplot website, right? So you're going to go to ggplot2.tidyverse.org, okay, and this will take you to the kind of the ggplot website, and I strongly recommend getting the cheat sheet. Okay, the cheat sheet is a good place to get started as far as what kind of plot is it that you want to make, and so they have just these tiny little thumbnails of what the plot might look like, and you might go, oh, this is the thing I want to make, and then you'll know, oh, okay, for that I need to call geom_smooth, okay? Or you might say like, oh, this is the thing I want to make, okay? I want to do geom_contour, or whatever it might be, right? So there might be just some of the different geometric objects that you want to create, and you can kind of look at this, and you know, and they have them separated out basically based on one variable and two variables, whether it's discrete or continuous and things like that. And so these are this is a good starting point. And once you've decided upon what type of geometric object you want to use, then you can just go over to the reference, okay? And this will list all of these things out, okay? And so under layer geoms, for the geometric objects, you can say, oh, the thing I wanted to do was a box plot, and you can kind of click this, and then and they list off basically all of the different aesthetic attributes that that can be mapped, or the settings that can be changed. So this is all of the aesthetics. These are all things that can be mapped to a variable. Okay, these can all be mapped to a variable, and then they often plot a lot of examples of the kinds of things that can be done. Okay, and so the examples are very very useful as well, right? So so this is a very good place to start, and then there's all sorts of different different things to fix up. Okay, so anyway, get accustomed to searching online, and I would say you should start at the reference site. Okay, start at the documentation, because this will always be up to date with the latest thing. You might sometimes you'll go online and you'll just search, and the first thing that comes up will be like a Stack Exchange thing, and those are often helpful and good, but sometimes you should always check the date on which those things are posted. They might be like 3 years old or 4 years old or something like that, and they might be using commands that have been deprecated or no longer are used or have been retired. And so things in the software world are changing rapidly, okay, especially with stuff like ggplot your R packages, your Python packages, they change rapidly, and things that worked a few years ago no longer work today. So it's important to kind of keep up to date there. All right, let's just start off with some bar graph basics, okay? And so here I'm going to load up this data called PG underscore mean, okay? And I think this comes in either in one of the packages, either the graphics cookbook, okay? And so the thing is I think I saw some people on Piazza asking about the vehicles data set, which column represents city miles per gallon and stuff like that, okay? If you're not sure about the columns or the values in a data set, you can always put in a question mark and the data set name, especially if it's loaded from if it's loaded in a library package, right? If you call data whatever to load the data, there will be a help file that explains the details of the data set, okay? So in this case, it says means of results from an experiment on plant growth, okay? And so PG underscore mean represents plant growth mean. There's other things, like empty cars, which is a data set we often reference. Motor trends, car road tests. It will have a list or it will detail out all of the variables and their information, okay? The iris data set, you can always type stuff like that in, and it will have information about the data set, okay? Obviously, if you download a CSV file off the internet, okay, R is not going to know about it. You got to look at that website to find out the information about the variables on that CSV file you downloaded. But in general, if you've called data to load up the data within R, you can ask for help on it, and it will do this. Okay, so anyway, we've got 3 values here. Under group, we have control, treatment 1, and treatment 2. And under weight, we have these 3 things. And so if we want to create a bar plot, we would just map the group variable, control, treatment 1, treatment 2, to the x-axis, and that will position them across the bar, and then the weight variable gets mapped to the y, okay? And because we want to actually have the height of the bar determined by this value in here, we're going to use stat equals identity, okay? Here's another data set, Cabbage Experiment data. This comes from, we have 2 types of cultivars, different types of cabbage, I guess, Cabbage 39 and Cabbage 52, and we took weight measurements and stuff on day 16, day 20, day 21, and things like that, okay? And so all of this is recorded here. And so, just try to visualize in your head what this plot might look like, okay? I've mapped the date variable to the x-axis, the weight variable to the y, and the cultivar to the fill, okay? So how many positions on the x will I have bars? Okay. I've got 6 observations and 3 dates, D16, D20, and D21. So we're going to have 3 positions for the x, okay? The weight will be just these unique weight values. And the cultivar, I have 2 cultivars, C39 and C52, so we're going to have 2 colors there, okay? We're going to, again, use stat equals identity, and this is our resulting plot, okay? So we can see we've mapped the date variable to the x-axis, the weight variable, that column goes to the y. The cultivar column gets mapped to the fill color. And again, ggplot automatically creates a guide or a legend for us that says, this color corresponds to this cultivar and this color corresponds to the other one. In all of these things, we've been using geom_bar stat equals identity. But there might be an instance where you don't want to use stat equals identity. And so here's an example where I am looking at the diamonds data set, okay? The diamonds data has close to 54,000 rows of data, okay? So it's a very big data set. I'm just looking at the first 6 rows, okay? And there's one of the variables is cut, okay? This is an ordinal variable or an ordered factor where, you know, when you go out and buy a diamond, you know, there's things you have to consider: the size of the diamond, the carat, you know, the color of the diamond, you know, whether it's like looks clear or not, and stuff like that, and the clarity and things like that, and the cut. The jeweler has to cut the diamond, and if he did a bad job, it's going to be rated poorly, right, or fair or something. So, in this case, this is the summary bar chart of the 54,000 rows. It went through and it counted up how many times did it see ideal, how many times did it see premium, and stuff like that, and it creates the bar graph accordingly. Okay. You'll notice that we've mapped only one variable, and it's the cut variable. Okay, the cut variable gets mapped to the x. Nothing gets mapped to the y because the default statistic being counted, default statistic calculated for geom bar is the count. Okay, so when you call geom underscore bar, it runs generally with stat equals count, which means it's going to count them up and produce bars of that height. Cut has been arranged on the x-axis in order of its variable. It's not alphabetical, okay? Because very good, V comes after P and P comes after I, but they've been arranged from kind of the order specified, probably in the factor, as far as, you know, which one's the worst and which one's the best, okay? To arrange them this way. Here's another data set. This is from the data set US population change, okay? And if we ask about US population change, this data frame, again coming from the graphics cookbook, we're looking at kind of the population from the 2000 census and 2010 census, okay? And so in the 2000 census, there were, you know, people living in different states, and then in 2010 the population had changed, and we are recording how much the population has changed. And so in Arizona, which is in the west region, considered in the west region, its population increased almost 25% in that 10-year span, which is quite remarkable, okay? And even, you know, more so, Nevada jumped up 35%, okay? So there used to be, if there were 300 people, it jumped up to 400 people, right? So that's quite a bit of a population change. And anyway, we're looking at just where the populations grew, and they all seem to have happened in the west and the southwest, at least if we look at the top 10 population changes, okay? And so, you know, census will happen next year. We'll see what happens there. And anyway, you know, Texas grew 20%, things like that. And so we can graph this, okay? And here we're gonna map the state abbreviation, okay, to the x-axis. Arizona, Colorado, Florida, things like that. Utah gets mapped to the x-axis, and that value that appears in change will get mapped to the y-axis. The height of the bar is determined by that. We're using stat equals identity, and here I'm going to take this region column, which says the state is either in the west or the south, and that's going to map to the color, okay? And so we have kind of this reddish orange salmon color for south and this blue green teal color for the west, okay? Over here, this should say mapping a numeric variable, not categorical. Numeric variable to color. All I've done is I've changed from region being mapped to fill, I mapped change to fill, okay? So change is mapped to the Y and change is mapped to the fill. So there's a little bit of redundancy in this graphic, but it maybe further emphasizes maybe the point I'm trying to make here, okay? And we can see that because change is now a numeric variable, that this vertical bar, this guide shows us that the largest value is 35, and it is going to be this light blue color. and you know, kind of the smallest values are maybe like 15, and that gets this dark, almost black color here, okay? And then everybody else is, you know, some shade in between black and light blue. Okay, and so this is what the plot looks like here. Now, with this, I can further emphasize whatever it is I want to say with this graph, and I can say, you know what? Let's arrange these from. Let me see if I can. Okay, you can't. The legend got cut off here, but here I have changed in the aesthetic mapping. I'm saying don't just take abbreviation, but reorder abbreviation based on the change variable. Okay, reorder abbreviation based on the change variable, and that will go on the x-axis. Okay, and so you can't see it, but you know the smallest one, South Carolina, is over here, and Nevada and Arizona with the largest changes are over on the right. Okay, and so you know, again, because we've got change appearing so many times in the aesthetic mappings, a lot of this information is redundant in that you don't need to see the colors going from dark to light to also notice that the bars go from short to tall, and to notice that they go from small to, you know, whatever it is that we're trying to say. But it does kind of emphasize, when you look at the color gradients, you see the difference between first and second is very pronounced, okay? And so is the shading of the colors, okay? This is a lot lighter than this, whereas these ones, there's kind of a smooth transition going from the dark to the light, you know, this blue color, and then there's a sudden jump here. And so if that's what you're trying to say Nevada had a much bigger growth spurt, population jump than any other thing, then, you know, this graphic where there's a lot of kind of redundant things going on really emphasizes that point, okay? And so anyway, these are just different things you can do as far as the bar graphs go, okay? Here, if you wanted different colors, if you don't like this default coloring of teal and orange, red, orange, okay, you can choose to alter scale fill manual, okay? So again, a scale is how do the values in the column map to aesthetic properties, okay? Visual properties. And so in this case, by default, ggplot says south will get orange, red, and west will get teal. And you might say, well, I don't want orange, red, and teal. I want, you know, UCLA colors of blue and gold. And so you can specify that here, okay? And again, you can always go to the reference thing, and you can choose look up scales under the reference manual and say, okay, how do I want to do any of these things, right? And choose one of these things. So there's scale fill manual. You have a bunch of you have some default choices from kind of color brewer, which not default, but you can have kind of different color scales to represent different things depending on the you know, visualization stuff that you want going on. All right, so this is one thing you can do. Same thing, you can do it for a kind of the scale gradient. If you want the small value to be red and the large value to be blue, you know, this really emphasizes the difference, right? There's kind of a smooth transition going from red to purple here, and then there's a huge jump going from purple to this blue color here, okay? And so, you know, that's done using scale fill gradient. Low is red, high is blue, things like that, okay? And again, there's all sorts of different options that you can look up using the ggplot reference. Okay, let's talk briefly about line graphs, okay? Line graphs are basically like making a scatter plot except you connect the dots with lines, okay? And so in this case, I've got 6 values, 1, 2, 3, 5, 7, and this column called demand or whatever. And we're going to say time, this time value goes to X, and the demand column goes to Y, and we're going to just say geom line, okay? And geom line is going to connect them in kind of the order that it sees here, all right? And so this is what we get, okay? Depending on your data, you might have multiple lines. And so here I have taken some data here. This is tooth growth data from guinea pigs, and I guess this is something scientists are interested in. They want to know how much the teeth of the guinea pig grew based on whether they gave them orange juice or vitamin C, because who knows, right? So anyway, this is what we've measured. There were a bunch of things, and I summarized them based on the mean values here, and so we've got 3 columns: the supplement, whether they got orange juice or vitamin C, the amount that they got, 0.5, 1, or 2, and then how much the teeth actually grew. Okay, and so when we do this, you can call map the dosage, okay, 0.5, 1, or 2 to the X. The length, this column, the numeric variable, goes to the Y. And here we can say color. The color is mapped to the column supplement type. So orange juice will get this line up top. Vitamin C gets the line on the bottom, okay? And we have different colors here. Okay, and so that's an option. If you're printing this, okay, and you have a black and white printer, you don't have a color printer or something, okay, you can choose to change the line type and have a solid line versus a dotted line, okay? Because maybe using red and teal look exactly the same when you print it on a black and white printer, okay? But you can use it this way. You know, this is not as visually striking because you know, obviously color is a important thing for our eyes to recognize, but you know, on plain paper this might not be an option. So you have to use, you know, solid lines or dotted lines, and I don't know how many line types it supports. I think there's like 5 different line types, but at a certain point, you know, the dash dot and the dot, you know, dotted dash or whatever is, they all look very, very similar at a certain point. But this is something that exists, okay? And you can also mess with the line thickness, whether you've got a fat line or thin line. These are all different things. So again, under geom, let's see, geom line and geom path, you know, there's different aesthetics that you can do, right? So you can have the X and the Y, but you can also change the size, the line type, the color. These are all aesthetics that can be mapped, okay? The aesthetic section is just properties that can be mapped to a variable, okay? Whereas everything else is kind of a lot of settings and stuff like that. All right, let's talk scatter plots, okay? So with scatter plots here, I'm looking at some height weight data, okay? And we have the age, the age of our the people that we've recorded, okay, going from around 12 to looks like 17, 18-ish, okay, and we're looking at the height measured in inches, okay, and so here we can see as age goes up from around 12 to whatever 16 something, there seems to be a positive relationship between age and height, and which makes sense. As kids get older, they get taller, okay, and this is the information that we've recorded, okay? If we take a look at this data frame, okay, we see there's other values that we can look at, right? So we've got the age measured in years, the age measured in months, their height in inches, their weight in pounds, but also the sex of the person being measured, whether they were female or male or whatever. Okay, and so we can map. Oh, here I've changed the point as a setting. Okay, and so these are, if you didn't want solid black dots, you can use open empty circles, and you can do that. And there's a list. You can just search Google or search the internet for ggplot shapes, and there will be a listing of circles and triangles and squares and X's and stars and things like that. If you want to use different symbols here, okay? I think don't quote me on this, but I think we can now even plot emoji symbols on the thing, right? And if you wanted whatever. You can change the size of the dots. You can have big dots, so this is size equals 3, and you can go as big, as big as you want. And of course, these are just settings, or they can be mapped to aesthetic attributes, right? So here I'm mapping the sex to the color, and what we can see is around age 12, there's a good mix. The blue and the orange dots, or the red dots, they're kind of just mixed together. There's not clear separation. But by the time we reach 16 or 17, there seems to be clear separation, that the blue dots tend to be up here and the reddish dots tend to be down here, okay? So somewhere there's a transition that happens that makes it from being difficult to separate to easier to separate, okay, as far as distinguishing sex based on height and things like that, okay? So anyway, this is just something we're just mapping one of the columns to a visual attribute of the geometry, in this case the point. Again, if you're dealing in a black and white situation, you can say, let's map it to the shape, okay, not the color. And so now females get circles and males get triangles, and that's just default because F comes before M in the alphabet, and so the first thing usually gets the circle and the second thing gets the triangle. But again, you can control this manually, and you can say, I don't want circles and triangles, I want stars and squares or whatever, okay? And that's allowed, okay? And you just do you would look for scale, shape, manual, or something like that. All right. You can, so far all of our plots have been using one data frame to plot the thing, and I just wanted to show you some examples where you can use multiple data frames to create plots, okay? So here is a very basic plot. It says sine x, but it's actually cosine of x, okay? And I've just created a function where we're gonna just make cosine of x, and I just ran it through here. This was unnecessary, okay? But you might have a more complicated function, because cosine of x is a vectorized function. You can give it a vector and it spits out a vector. But if you had an if statement somewhere in your function, this wouldn't work. But I mean, you would need to run the for loop. But anyway, all to say, I have x and I have f of x, and I put them into a data frame, okay? So I created a data frame called function data with an x column and an f of x column, and we're going to map the x column to the x position and the f of x column to the y position for a geom line, okay, for a line thing. And when we do this with option blue and size equals 1, this is the plot that we get. Cosine graph, we're all familiar with it. Let's say I wanted to add additional information to this plot from a different data frame, okay? So this data frame that says function data has data about this blue line, but let's say I wanted another data frame and I wanted to add that to the plot. So here I'm creating a new plot called df points, data frame of the points, where I've just taken some random y position data, okay? I said random normal, centered at 0 with a standard deviation of 0.5, okay? And x just goes from 0 to 6, okay? So we've got, 7 values there. I'm just gonna have some random points added to the thing. So earlier we've created this ggplot with the geom line, ggplot is working off of function underscore data. Over here, I'm going to add points, all right? I'm going to add points, but this time the data is coming from df underscore points, okay? So I have this thing which has the data frame for the cosine data, and I've got this data frame for the point data, and you can just add them together, and ggplot figures it out, and it adds kind of our dots to the plot here, okay? I guess I have like 15 dots here. I don't know, 13 dots? Something, okay? So we've just added some dots to our data frame, and dots to our plot, even though they're coming from two different data frames. And then furthermore, if you want to add line segments or something like that, if you have another data frame, so here I've created another data frame with 4 columns, x1, y1, x2, and y2, okay? Because so here I'm going to use geom underscore segment, which we haven't covered, but it's pretty easy. Each row will correspond to a line segment in our plot, and each line segment needs to have an x and y coordinate for the start and an x and y coordinate for the end. So you need to have 4 values to be mapped to the line segment, and so you need to have at least 4 columns in your data frame, so which is what I have. I've got a column for x1, a column for y1, a column for x2, and a column for y2, and I just map those to the x and the y and the x end and y end, which are the properties that are needed to create segments, okay? And here I'm going to create 8 segments. Each of these segments are just generated randomly, okay, using R's rnorm function, okay? So this is just going to add 8 random line segments to the plot, okay? And this is what we get, okay? This plot means absolutely nothing. It's just a cosine graph with random dots and random line segments added to it, but they are coming from different data frames, and I just wanted to show that that's possible. All you have to do is specify that the data itself is coming from a different data frame over here, okay? And so you can combine information from different data frames as long as you're calling new geometries to the plot and specifying where the data is coming from. Okay, we'll end here for today, and then we'll see you guys on Wednesday.